Hi everyone. Today we're going to be talking about the real numbers, lesson 310. You're going to learn how to classify different types of numbers and the families that they belong into. The chart that you see here is really nice to use if you want to see which number belongs in what family, and some numbers belong in multiple families. The natural numbers, I'm going to start talking about those. Those are the numbers you would start off as a little kid. They're also called the counting numbers. So you would count 1, 2, 3, 4, 5, etc. That's your natural group. That's the smallest number group. Then the next one is one that we've been working with since chapter 1, which is the whole numbers. Now, your whole numbers include one other number compared to the natural numbers, which is 0. So the whole numbers include 0, and then it goes 1, 2, 3, all the whole numbers through infinity. The ... means it just keeps on going. Then in chapter 2, we looked at the integers, which are the whole numbers and their opposites. So that includes the negative numbers as well. Still no fractions and decimals, but it's the whole numbers and their opposites. So each group builds on the last. Notice the natural numbers are inside the whole. So the natural numbers sit inside the whole numbers, which means if a number is a natural number, it also is a whole number. But it doesn't go the other way around. Not every whole number is a natural number. For example, 0. 0 is not a natural number, but it's a whole number. The integers is the next larger group. It includes all of the whole numbers and all of the natural numbers. The group that we've been talking about during this current chapter are the rational numbers, which are all of the numbers we've just spoke of and fractions and decimals. They belong to the family of rational numbers, so that's when you'd get like 7.2, 9.8, 7.5, 9.5, etc. Then you have kind of a family off on its own, and it's the irrational numbers. They are decimals that go on forever. So that's here. Decimals that do not terminate, meaning it doesn't end or repeat. They go on forever. But they also don't repeat. So it can't be like 8.3333333. That repeats. So that would not be an irrational number. That would be a rational number. Irrational, they do not repeat, and they have no end. So like the number pi, and also like the square root of any number that's not a perfect square. So like square root of 17, square root of 19, square root of 20. Those would be irrational numbers. They go on forever without repeat. The real numbers are the set of everything. So all the rational, all the irrational, all the ones that we've spoke of so far. Now, what would be the opposite of a real number? That would be an imaginary or a not real number. And those we talked about briefly, and they were the square roots of negative numbers, because we can't come up with what two numbers multiplied to give you -9 that are the same number. So that belongs in the family of imaginary numbers. Also, if you try to divide by 0, that's an imaginary number as well. So, or they also call them not real. So not real or imaginary be the square root of negatives, or if you divide by 0. So let's go down to our chart. I don't know why the writing's still staying there. All right, so let me recap what we just saw above. We'll talk about the natural numbers. Remember, I also called them the counting numbers, so they would be what you would count with. 1, 2, 3, 4, and so on and so forth. The dots just mean they go on forever. The whole numbers are 0 and the natural numbers, 1, 2, 3, 4, and on forever. The integers include the whole and the natural, and they also are the negatives of those as well. So -3, -2, -1, 0, 1, 2, 3. And remember, the ... dots mean they go on forever, in this case in either direction, positive and negative infinity. Rational numbers include everything that came before it and all of your fractions and decimals. So 7.4, 9.5, -4.2, and all of the numbers that came before it. Remember, your irrational numbers are square roots of numbers that are not perfect squares. Square root of 7, pi, go on forever without repeat. Square root of 20, we don't know what the square root of 20 is, so it's a decimal that goes on forever without repeating. Real is the entire family of real numbers. All of these can be put into your calculator. That's what would be real. Not real are numbers that are undefined. You can't put in a calculator, so dividing by 0. The square root of negative numbers. Those are your two big pieces that would be in the not real family. Let's try some examples. One of the things I'll have you do is you will have to write all the names, all the families that apply to each number. Simplify the number if you can first. So for example, square root of 3, we have to think about what family that belongs in. Square root of 3 is a number that we don't know the square root of, so it is in the irrational family, and all irrational numbers are also real. Negative 9.45. First of all, I see that there's a decimal. That tells me it's rational. And it also belongs to our big family of reals. It can't be a whole number because there's a decimal. It can't be an integer because there's a decimal. Can't be a natural number because there's a decimal. So the first family it can belong into is the rational. The next one, can I simplify the square root of 16 over 2? And the answer is yes. The square root is not over the entire fraction, so it's over the 16. I need to do that first, according to PEMDAS. So I have 4 divided by 2, because the square root of 16 is 4. 4 divided by 2 is 2. So now the actual number I'm looking at is 2. And what families does 2 belong in? Well, the counting family, which is the natural family, includes whole numbers like this. So it's natural. You could also say counting. Does it belong to the whole family? Yep, whole, which makes it an integer because it includes all the things below it. Rational. And then real. Negative 82. So there's no decimal, but it's negative. So that makes it an integer. It belongs to the family of the rationals, and it's real. Square root of 34. 34 is not a perfect square, so we don't know the square root of it. It's going to be a non-terminating decimal, which makes it irrational, and then also belongs to the reals. 6/7, a fraction, so I know that falls in the rational numbers, which would also make it real. The next section has a little bit different directions. It says, state if the number is rational, irrational, or not real. So they just have very simple directions: rational, irrational, or not real. The first number, square root of 17. So the square root of 17 is not a number that we know the square root of off the top of our head. It's not a perfect square. So that would make it irrational. 0 divided by 6, if I can simplify it, I will. 0 divided by any number. How many times can 6 go into 0? That's 0 times. So that number is going to be rational, because it belongs to the whole numbers, it belongs to the integers, rationals, and the reals. Square root of a negative number. Remember, that's not something that we can do. We can't come up with a number that multiplies by itself to get you negative 9. So that is called not real. Square root of 4/9, I can break that up. Square root of 4 over square root of 9, which is 2/3. 2/3 looks like a much more normal number. That is rational. 5, normal number, rational. It is a natural, whole, integer, rational, real. Square root of 36, do we know that it is a perfect square? So that's good. It's 6. So simplify any of these that you can first so that you can identify them. And it's a rational number. Square root of 82, we don't know the square root of 82. So it falls in the irrational family. And they're just asking us for rational, irrational, or not real. 7.8 is a normal decimal, so that's rational. It also falls in the real family as well. And then 7/9 normal fraction, rational. So really the only weird ones you want to look for, so let's talk about this for a second. The irrational ones are the square roots of numbers we don't know, they're not perfect squares, or pi. Not a real number are the square roots of negatives, which remember don't exist, or if we were to divide by 0. And then the last thing we're going to talk about is a little bit off the beaten path, but we're going to be talking about cube roots. A cubed root, so remember, square root is what two numbers multiply together to get you to that number, but they have to be the same number. Cube root is the opposite of cubing, so it means what number times itself 3 times will get you the number underneath the cube root symbol. And so what number multiplied by itself 3 times is going to get you 8? 2. 2 times 2 times 2 is 8. So 2 is the cubed root of 8. And we'll try these ones down below. The cubed root of 64, I'm going to go out of order just for fun because I circled cube root of 64, would be 4. 4 times 4 times 4 is 64. Cube root of 27, any guesses? That would be 3. 3 times 3 times 3. And the cubed root of 125 is 5. When you start cubing a number, it becomes really big, really fast. So doing a cube root, I don't ask you to do many of these, but we just wanted to explore those for a moment. All right, have a great day. Work on your homework.